Welcome to All This Math. This is Professor Parker, and in this particular video, we're going to actually do some algebra that I actually think is kind of fun, right? There's certain skills and certain topics within algebra that I actually think are fun. Like some stuff I know how to do, and I'll show you how to do it, but it's okay. But then there's certain topics and certain skills, like finding a quadratic equation when you're given a pattern of numbers, that I actually think is kind of fun. And I also want to send a shout out to Camille because I was tutoring Camille the other day and I had to brush up on my notes to remember how to do these types of problems. So I want to thank him for putting the battery in my back so that, I would get back into my notes and, refresh my memory in terms of how to do these problems, because I forgot that I actually enjoy doing these. I actually enjoy teaching this skill. Okay. So now for you, when you see a problem like this, after you watch this video, hopefully subscribe to the channel, by the way, save this video. So whenever you see a problem like this, you can just refer back to it and say, okay, boom, I know how to do these types of problems. All right. Because there's a specific set of steps that you can take to do these types of problems. Now, this is not the way I'm about to show you is not the only way to do these types of problems, but it's definitely one way that is duplicatable and that will work. All right. So let's get it started. Now, again, read the question or read the instructions. It says to find the quadratic equation from this pattern. Now, what is the pattern? You have 6, you have 13, you have 22, and you have 33. So you're probably looking at that like, how am I supposed to do that? What do I do? All right, I'm going to break it down for you step by step. First thing you want to do is you want to create a table, right? Create a table of values, right? With two columns, you're going to have an X column and a Y column. So it's going to look like this. You got X and you got Y. But you should be thinking, well, how do I have an X column and a Y column if I only have one set of numbers? Do I put a 6 here and a 13 here? Do I put a 22 here and a 33 here? No. All of these values are going to be considered your Y values, right? Your X values are going to be kind of like the order that they come in. So the first number is a 6. The second number is a 13. The third number is a 22. The fourth number is a 33. So think of it as the order that they're in, those are your X values. The actual number themselves, those are the Y values. So your number pairs or your ordered pairs are 1 and 6, 2 and 13, 3 and 22, 4 and 33. See how I did that? My first number was a 6. I got 1 and 6. My second number was a 13. I got 2 and 13. My third number was a 22. I got 3 and 22. My fourth number was a 33. I got 4 and 33. All right? So now I got my table. Now, the next thing I need to do is I need to find something called my second difference. My second difference. Now, before I find my second difference, I need to find my first difference, right? So I'm going to find my first difference, and then I'm going to find my second difference. But the second difference is what I really need, right? And that's also a way for me to verify that this, in fact, does represent or can be represented by a quadratic equation, right? Because if my second difference is not a constant, is not the same number every time, then that means that this is not a quadratic equation. So when I say first difference, what I mean is like, what's the difference between each Y value? So think about it like this. What's the difference between 6 and 13? 7. What's the difference between 13 and 22? 9. What's the difference between 22 and 33? 11. So we have 7, 9, and 11. Now those are my first differences. 7, 9, and 11. Now we go to the second difference, meaning what's the difference between these three numbers, the 7, the 9, and the 11? The second difference is the difference between these three numbers, the 7, the 9, and the 11. Now, what's the difference between 7 and 9? 2. What's the difference between 9 and 11? Also 2. So again, this just verifies that these numbers can be represented by a quadratic equation. Okay? Now, since we just verified that they can be represented by a quadratic equation, I want to write down the general form of a quadratic equation. So that's going to be your next step. Write down the general form of a quadratic equation, which is this. Y equals ax squared plus bx plus c. That's the general form of a quadratic equation. You see it's quadratic because the biggest exponent you see is the 2, right? You have x to the second power, x to the first power, and this is a constant. A is a coefficient of the x squared term. B is a coefficient of the x term. So this is the general form of a quadratic equation. All right? Now, what I need to do is this. In order to find the actual equation, I need to find the values of A, B, and C. Right? That's what I need to do. That's my goal. That's my goal. That's my end game. My end game is I need to find out what number represents A, what number represents B, and what number represents C. That's what I'm trying to get into. I'm trying to find out what A, B, and C are. And there's a specific way that we can do that. All right? Now, first I want to find out what A is. Now, the way I find out what A is I use this formula. 2A is equal to the second difference. 2A is equal to the second difference. Again, 2A, 2 times A is equal to the second difference. Now, we did this work over here. So we know what the second difference is. The second difference is 2, right? Remember, we talked about that because we talked about the first difference. First differences were 7, 9, and 11. Now, the second difference is 2, right? So now I get to set up a little light equation. 2A is equal to 2. Because the second difference is 2, because we already proved that. We talked about that a minute ago. That's old. We've been did that, right? So now I got 2A equals 2. Now I do my little simple algebra, right, to solve for A. Divide by 2 on the left, divide by 2 on the right, and I get A equals 1. So that's one of the pieces of information that I need. So I know what A is now. But now I still got to find out what B and C are. Now, the way we're going to figure out what B and C is that we're going to set up two equations that are going to end up being equations with two variables in them, B and C, that is. And then we're going to solve a system of equations with two variables, a 2-by-2 system of equations, if you will, right? Now, what does that look like? That looks like this. I go back to the general form of a quadratic equation, right? General form of a quadratic equation. And I use this first point, which is 1 and 6. And actually, you can use any point you want. But I'm going to use the first point, right? Because that's just what I do. I use the first point and the second point for this next step in the process. First point is 1 and 6. And then I just plug in y and x. I plug in the value of y, which is going to be 6. And I plug in a 1 wherever I see an x at. Because that's the value of x for that particular point. Right? Now watch what happens. So I got 6 equals a. Now I know what a is, so I don't got to use a because I know what a is. Remember, in algebra, we use variables when we don't know what the number is. Sorry about that. Lights went out. Wasn't moving around enough, I guess. All right, so anyway. So, like I was saying, I don't need to use the variable a because I know what a is. A is 1, right? So I got 1 times. Now, I know what x is also. X in this case is also 1. So that's going to be 1 squared plus b. Now, I don't know what b is, so I got to use b. And then I got x is still 1, right? And then I got plus c. And now I want to simplify this, right? I'm going to simplify all this. So this is going to become 6 equals 1 squared is 1 times 1 is 1. B times 1 is b. And then plus c. And then I'm going to simplify this, right? B plus c is going to equal 5. B plus c is going to equal 5. Where does the 5 come from? It comes from me subtracting 1 on the right side and subtracting 1 on the left side. And then I flip everything around so I can read it from left to right. B plus c is equal to 5. Right? Because that's standard form for a linear equation. Right? So now I got two linear equations. That's what I got. I got two linear equations now, right? So now that's one of my equations that I'm going to use for my 2x2 system. Now I got to pick another point. That's why it's so important. That's why it's so important and so helpful to do your table of values from the beginning. I already used 1 and 6. So now I'm going to use this again, the general form of a quadratic, with a second point, right? So now I'm going to put the 13 in, equals a, and I know what a is. That's 1. And then x is, in this case, is 2 squared plus b. I still don't know what b is, but I know what x is. X is still 2, right? And then I got plus c, right? And now I'm going to simplify this, just like I simplified this. I simplified this, now I'm going to simplify this, all right? So now I got 13 equals, now, you don't do 1 times 2 and then square that. You don't do that. You follow the order of operations. So you do 2 squared, which is 4. 4 times 1 is 4. And then you do b times 2, which is 2b. And then you got plus c. And then I'm going to end up with 2b plus c equals 9. Equals 9. Where does the 9 come from, though? Where does the 9 come from? Subtract 4 on the right, subtract 4 on the left. 13 minus 4 is 9. Subtract 4 on the right, subtract 4 on the left. It's 9. Now, technically, it'll be 9 equals 2b plus c. But I want to read the equation from left to right. So 9 equals 2b plus c. But can I just say 2b plus c equals 9? Isn't that the same thing? Just like up here. I would have had 5 equals b plus c. But can I just say b plus c equals 5? They the same thing. So now I got my two equations. So now I'm about to find out what b and c are, and I'm about to be done. All right, so let me go over here. Use a different color, right? So everything don't just, bleed together or whatever, or blend together, I should say. Now I set up my system of equations, my 2x2 system. I'm going to put b plus c equals 5, because that came from right here. It came from right here, right? Remember that work we did to get that? And then I'm going to have 2b plus c equals 9. Because that came from right here. From all the work we did right here. That came from right here. Now, my goal is to solve for b and c. I need to solve for one variable at a time. I can't solve for two variables at the same time, though. I got to solve for one at a time. Now, some of you that are familiar with this, you know that you could either use the elimination method, substitution method. You could use the graphing method. I don't know why you would, though. If you know a little bit about matrices, maybe you use Kramer's rule. But I think the easiest thing to do is, let me say this. I like doing substitution method sometimes. That's what I'm in the mood for. So I'm going to change this right here into b equals 5 minus c. b equals 5 minus c. Now, why did I do that instead of using the elimination method? There's no real reason. I just felt like doing it. If you feel like using the elimination method, go ahead. Do that. That's cool. Just as long as you accurately solve for b and c. So b is equal to 5 minus c. Now, because of that, then I go here and I replace this b with 5 minus c. The purpose of doing that is so I have an equation with just one variable in it, right? Even if it's written in two different places, I need to only work with one variable at a time, right? So now I got 2 times 5 minus c plus c equals 9. You got parentheses right here. We got to do the distributive property thing. So 2 times 5 is going to be 10. 2 times negative c is going to be negative 2c. And then plus c, and then equal sign, and then 9. And then I got to combine like terms. So then I got 10 minus c, because what's negative 2c plus c? That's like saying negative 2 plus 1. Negative 2 plus 1 is negative 1. So that's negative 1c equals 9. And then I got to get rid of the 10. Minus 10 minus 10. Then I got negative c. Don't forget that negative sign. A lot of people like to forget that negative sign. Don't forget that negative sign. 9 minus 10 is negative 1. Now, I'm trying to solve for c. So I got to get rid of that negative sign. I can do divide by negative 1 and divide by negative 1. And I get c equals positive 1. So c equals positive 1. So now I got my a and I got my c. And now I'm about to get my b. Once I get my B, I'm going to be done, and I'm going to just be able to write my answer. So watch this. Now I got B equals 5 minus C, but I don't need to write C because I know what C is. C is 1. In algebra, we use variables when we don't know the number. Once you know the number, you don't need the variable no more. You don't need the letter. So 5 minus 1. So we got B equals 4. So I know my A, I know my B, and I know my C. And remember I told you? So you always should have an exit strategy or an end game, right? In anything you do in life. I told you before, like early on in this problem, our end game is to figure out what A is, B is, and C is, right? We have goals, we have objectives. We fulfilled our goals and objectives. We know what A is, B is, and C is. And now we just write our answer. Our answer is Y equals X squared. Now, you might be thinking, well, why you ain't write the 1? Because when 1 is your coefficient, you don't need to write it. When 1 is your coefficient, you don't need to write it. I'm going to say it one more time. When 1 is your coefficient, you don't need to write it. All right? Now, B is 4. So that's plus 4x. And then C is 1. So that's plus 1. And that's our final answer. I know this seems tedious. It seems lengthy. But whenever you see a question like this, these are the steps you follow. And like I said, this is not the only way to do these types of problems. It's not the only way. It's the way I like doing them, right? If you find a different way that's, more suitable to your needs and to your feelings, then by all means, use that method. But I know I'm going to tell you, this method definitely works. Each of these steps that I told you, set up your table of values, find the first difference, find the second difference, then find out what A is using this formula. Using this formula, 2A equals the second difference, right? And then use the general form of a quadratic in order to find a linear equation using one of the points. Then use the general form of the quadratic again, using another one of the points, using X and Y values, to find another linear equation. Then set up a system of linear equations and solve for both of them variables. And you'll be done. Yeah, you'll be done. All right. And if you haven't already, please subscribe to the page. Please share the video. Tell some people about it. And always remember, there's all this math all around you. Peace.